All right, so in Calculus 30, we're going to study slopes of secant lines, and we're going to use the limits of those slopes as we bring 2 points closer and closer together to the point of tangency. We're going to use the limit of those slopes to approximate the slope of the tangent line. That's what 1.1 is all about here, okay? The tangent problem. So here's question number 8, and it says this: the point P20, okay, 20. Now that's an x-intercept, isn't it? 2, 0, lies on the curve y equals negative x squared plus 6x minus 8. So what do I know about this? Well, here's, you don't have to draw this, but here's 20. This is a point that's on this curve. Now what do we know about this curve? Well, it's a parabola because it's an x squared. It opens downward, and if we were to quickly factor this, we would see that we would have factors that would be, let's see, two numbers that multiply to 8 add to 6. So we're talking about 4 and 2, right? So if 2 is one of them, 4 is the other. So those are our x-intercepts. And we've got some kind of parabola that opens downward. So it doesn't really matter how high we go, but this is what it looks like, something like that, okay? So you have a little bit of an idea of what it looks like. If you want to graph this on your graphing calculator or on Desmos or something, you go ahead so you can visually see it. But you should be able to determine approximately what it looks like given what you know. So if Q is the point x, comma, and this is just f of x, right, the function. So this is going to be P here, and then Q is going to be some other point, Q like this maybe, okay? Find the slope of the secant line PQ. So this would be an example of one of the PQ lines, right? Secant lines. Find the slopes for the line PQ for the following values of x. So we know that x equals 2 is this point right here, okay? So what about if x was equal to 3? Okay, so let's just back up here and we'll erase some of this stuff here. Can I get that point? So if x equals 3, that's going to be this point right here. We're going to be talking about this secant line. I could draw. I'm talking about this secant line right here, okay? So what is the slope of that secant line? That's all it's asking, okay? No problem. So we're going to have to do this a number of times. Look at all these numbers, x's we're given. We'll have to do this a number of times, no problem. So how do we find the slope? Well, remember the slope is y2 minus y1 over x2 minus x1. That's what the slope equals. And this point right here is 2, 0. That's what x1 equals. This point over here is actually 3, comma, what's the y value? Well, it's kind of a big, long, involved one, isn't it? It's negative 3 squared plus 6 times 3 minus 8. So you have to find out what the value of the y is, right? Okay, so no problem. We can do that. So y2, okay, here we go. I'm going to do it the long way first of all so you can understand. So y2 is this value here. So what is that? What is that? That's 9, negative 9, okay, plus 6 times 3 is 18. So negative 9 plus 18 is positive 9, right? Minus 8. So that should be about a 1, right? So we've got y2 is 1. So this is the point 3, comma 1. You see that? All right, hopefully. Guys, check my work here while we're doing this. But we've got y2 is 1 minus y1 is 0 over 3 minus 2. All right, so we've got 1 over 1. So we've got a slope of 1 here for a I. Okay, slope of 1. Okay, is that good? Do you guys agree with that? Are you cool with that? So that's for I. Now for I, okay, we're going to be doing this over and over. The point is not 3, 1 anymore. Now the point, because Q is getting closer, now the x value is 2.5. Okay, so we've got 2.5 as our number. And what's the y value? Okay, well, here's where math takes some time. Okay, well, we've got negative, and we've got 2.5 squared plus 6 times 2.5, right, minus 8. That's our coordinates. Okay, so you can get your calculator out if you want. That's no problem. But you want to figure out what this y value is. okay? And then you're going to find the slope. So m equals, y2 minus y1 over x2 minus x1. So we've got the point 2.5 comma 0.75. That's this point right here. Makes sense. So let's do 0.75 minus 0 divided by 2.5 minus 2. That's 0.75 divided by 0.5. And that equals an m of, looks like 1.5. Okay. So here's our second line. Here's our second secant line. It goes like this, and it's a little steeper, isn't it? So this is m equals 1. This is m equals 1.5. That totally makes sense. So what we want to do is we want to find out what the slope is when we get closer and closer to 2. Okay. So as these x values here gets closer and closer to 2, what are the slopes turn into? And so let's just pause the video. Let's finish these next two here. So go ahead and work on that, and then we'll come back and we'll show you what these slopes equal. All right. So if you put 2.1 in there, you're going to get a slope of 1.9. And if you plug in 2.01 and find out what that is, okay, you're going to get a slope of 1.99. So here we kind of see that the slopes are increasing, and they appear to be slowing down and approaching a certain value, don't they? The next one probably would be 1.999, and then getting closer to, looks like, 2. So the second part here is test out now what happens when you have an x value of 1. So here's the x value of 1. So you're going to find out what this secant line slope is. And then of 1.5, so you're going to find out what this secant line is, and so on. And as the points get closer and closer to 2, we're going to approximate that tangent line. Okay? So you're going to find out for yourself what those points equal. So I'll get you started off here as well. So for number 5 here, if x is 1, well, if x is 1, we have negative 1 squared plus 6 times 1 minus 8. That's our coordinate there. And so that's going to be 1 comma, what's that? Negative 1 plus 6 is 5 minus 8 is negative 3. Okay? Looks like maybe a negative 3. So our slope is going to be, y2 is going to be this 2.0, right? 2 comma 0. So 0.1 is going to be 1, negative 3, and then we've got 2 comma 0 is our second point. So this is going to be 0 minus negative 3 and 2 minus 1, looks like. So we've got 3 over 1. So we've got a slope of 3 for this point number 5. So go ahead and continue with 6, 7, and 8 and see what numbers you get there. All right, so as we continue to complete the slopes of the secant lines, again, it's a little bit messy here to see, but as we move from x equals 1 to 1.5 to x equals 1.9, x equals 1.99, what we see is a pattern of the slopes. X equals 1, we have a slope of 3, 1.5. Here we have a slope of 2.5. When we have a 1.9, the slope turns out to 2.1. And then 1.99, the slope is 2.01. So I've summarized these slopes in this little chart here. And so as x approaches p from the right, we have slopes of 1, then 1.5, then 1.9, then 1.99. As q approaches p from the left, from the other side, then we have slopes of 3, and then down to 2.5, down to 2.1, 2.01. Okay, so again, kind of looks like this. Whoops, let me just draw this. Let me draw this a little neater. So again, I'll try and blow this up a little bit so it's easier to see. So over here, we have this kind of slope happening, boom. Then we have this kind of slope. Then we have this one. Then we have this one, okay? And over here in the red, the last ones we did, we have this slope, and then now this slope, and then this slope. And they're both kind of converging to this number, which appears to be coming to 2.00. So the slope of the tangent line, we could confidently say, as we work towards that, the slope of the tangent line is 2.0, or 00, or just 2, okay? And so this is how we'd write that. Remember that limit notation we learned in our lesson? The limit of the slope of PQ as Q approaches P is equal to 2, or 2.00. All right? Now, there is, to finish off this question, it says use the slope from part B to find the equation of the tangent line. So we've done that earlier in the lesson, but we can do that again. We do have the slope now, so the slope of the tangent is 2, and we do have a point. The point is 2, 0, right? So we can pretty easily use our point slope form, and we can plug in our values. So we've got 2 here, and we've got a 0 here, and we've got a 2 for the slope. So that's going to give us y minus 0 equals 2 times x minus 2. And this becomes just y over there, and this is 2x minus 4, looks like. So this should be the equation of the tangent line. Okay, that's the equation of the tangent line. Now, to see if we've done this correctly, and I don't think I'll do D because I think we kind of have done D, sketch the curve. Yeah, I kind of started to sketch the curve over here. This is what it looks like. What I'm going to do is I'm going to double check all this on Desmos, and I'm going to plug in the original function, and I'm going to plug in our equation of our tangent line that we've determined, and we're going to take a look at it and see if it does look like a tangent line at the point 2, 0 on the curve. So I've got now the original function, and I'm going to type in the y equals 2x plus 4, and oh, sorry, 2x minus 4. I hit plus. It should be minus. 2x minus 4. There we go. Okay, now that looks pretty good, actually, doesn't it? That looks like a tangent line at x equals 2. It looks like it touches the line just at one point there, and it looks perfect. Okay, so there you go. It looks like, once we've graphed it, it looks like we've done that pretty well. Okay, so that's question number 8 on 1.1. Using the slopes of secant lines on a graph to approximate or to find the limit in order to find the slope of the tangent line.